Hi, my name is Caylee, and I am in the process of setting up a manufacturing facility to make affordable titanium suppressors. You obviously need a lot of tools to do mass production of anything, and all these tools need air. So today we're installing air pipes and the bracketry and everything needed to hold it up. This is, of course, episode 3, as you can see by the title. Episode 1 was security, episode 2 was setting up my laser engraver, and now we're doing air. Here's the general plan. As you can tell, I've had electricians come in here and run conduit and 3-phase wiring for my lathe and then future additions. So I have all this Unistrut. This stuff right here is it's an industrial standard called Unistrut. Plenty of knockoff stuff for it though. It's basically a modular mounting system where you could run cables and wires and hoses and pipes. I like to call it Uni-Slut, because it'll take whatever you give it. You might notice that I've already started to hang some rubber air hose up here. I got about halfway and I was like, nah, it's too janky. I was just gonna do it just to get by for a little bit, but nah, I can't do it. I can't do it. So I'm gonna run pipe today. Let me show you my air compressor. All right, here's my little air compressor. This is gonna be running the entire shop. Right now I just have a lathe, a bar feeder, a little punch press, which is everything is mostly hydraulic or mechanical, but with a few pneumatic actuators. The biggest air need that I have is for air guns, just to blow off parts. And this will take care of it. It's been running pretty good. It's a Harbor Freight 26-gallon ultra quiet. It's pretty good. Get the 2-year warranty on it, just blow them up every couple of years. I mean, that's the way to go. All right, check out my bill of materials here. Over here we have our imaginary air compressor. That's going through a short piece of rubber hose right into this filter dryer. This is a 3-stage filter dryer and regulator. It'll bring down my 175 PSI air, bring it down to a more reasonable amount. So actually, I could just run this at 175, but I don't have to. That basically just gets most of the water out of the air. Each machine has its own water filter as well, but this, you want to get the vast majority out. Water is terrible for pneumatic systems, and you don't want any of that. So after that, I'm going to cut up some Unistrut, attach it where I need to, and then just build my PVC network. Let's just do it. Okay, here's my first fuck up. I bought these clamps. These are for 1/2-inch EMT, which is what electricians use. They're cushion clamps. That's what I wanted for the PVC, just to go through here. And I saw that has a gap. I'm like, obviously 1/2-inch PVC is gonna have a bigger OD because the walls have to be thicker than metal EMT conduit. So I'm like, yeah, it'll stretch, it'll be fine. So me, I'm a machinist. I assumed, like a dumbass, I assumed that 1/2-inch PVC, like every other pipe in the world, has a 1/2-inch internal diameter. We have an actual ID of 0.62, 620 thousandths of an inch. I understand that it's nominal, but that's almost 5/8 on the ID. Okay, and then the OD is 850 thou. That's almost 7/8. I should have bought 7/8 clamps for a 1/2-inch pipe. See, tubes, when you buy tubes in the machine shop, they're by the OD, right? Because a tube is structural. So you buy 1-inch tube, you're buying 1-inch OD. You buy pipe, shit goes through pipe, so I expect the ID to be what it says. But no, because dumbass system. I don't care if you understand it, it's still dumb. Just tell me what it is. Tell me the sizes, please. Like, just, it's dumb. Tell me what it is. Well, I stayed late last night and I got the pipes. They go all the way up here. They go up and over and down. We have a drop to our lathe manifold with our 2 outputs for the lathe, bar feeder and air gun. And then on the other side of the shop, we have a drop in the middle of the run. It goes over and then down to our final manifold here, which is just another air feed for the stamping press and some more air guns. But I came in today and I was reading the PVC cement bottle and I was just trying to see how long do I have to wait for this to cure before I could put air pressure in it. And I was reading this and it says allow 15 minutes for good handling strength and 2 hours cure time before testing pressure up to 180 psi. And then in all bold, it says, do not test with air. So I looked up how much, like obviously this is 600 PSI rated PVC. You don't want to run 600 PSI of air through it, but I only need like 50 PSI, maybe 60 max. Well, turns out it's an OSHA violation to use any sort of exposed PVC for air use. Can't do it. I guess somebody blew up some PVC, it gets brittle over time and then it explodes and it hurts people. So even though I've been using PVC for high pressure situations my entire life, even though I've worked in shops where we had PVC everywhere, I'm starting to realize that maybe those shops and also me were wrong and that you're not supposed to do that. And you know, I've been saying this every single time I do a job, I want to do it right. I just want to do it right the first time, so now we're doing it right the second time. Let's go to our new materials list and see what we got. Okay, now you're looking at about $500 worth of more supplies for this very simple job. We have 1/2-inch M thickness copper. This is M wall thickness, not L wall thickness. I think L is recommended because it's a thicker wall, but again, I'm using 50 PSI of air, and this is so much more than I need. I have these ProPress fittings. They are off-brand ProPress, and then I have an off-brand ProPress crimping tool. This was about $100, which is honestly super affordable compared to what these sort of crimp-on copper fittings used to be. These were about $30 a piece. It's not bad. It really isn't that bad, and I feel better about the copper. It's going to look cooler. How to get some specialty tools for this. It's not a big deal. I'm just pissed I did it wrong the first time. And ironically, these rubber isolator clamps that I bought for the PVC that end up being way too small for the PVC, they actually are made pretty much specifically for this copper. I mean, it fits on there perfectly. So all the other pieces I bought, all the Unistrut, that works. So I just have to rip down the PVC. I'm gonna save it. I wanna run some water lines to the machines for coolant, but yeah, let's just do another build montage, I guess. Did my electrician use 3/4 inch clamps on all these 1/2 inch? Let's see, Unistrut 3/4 inch. I see you, Charles. Okay, it's plumbed, I think. I'm pretty sure I have all the lines crimped. If I don't, I'm gonna find out in about 2 seconds. There shouldn't be any leaks. The shop's quiet, I don't hear anything. Okay, let me just take you along the track and then I'll give you the most fucked up mix of units and then we could check for leaks as we go. So starting here, the tank is obviously at a higher pressure. It's at 180 PSI. The regulator is down to 90 PSI. And then we go into my filter dryer 3-stage. That is at 6 bar. Then we go up, over, we tee down into my lathe manifold here. You can see on the lathe tag, it calls out 0.4 through 0.7 megapascals. And I'm running at what am I at? 0.55 megapascals. I think that's right about 6 bar. Okay, now on the front of the lathe, we see that T comes back up, goes over, T's down to an air fitting. That is still PVC because I don't have the fittings to make that copper right now. They're on the way. And then we go back up over a 90, down into our stamping manifold, which just has an air gun, and then 2 feed lines. I don't need 2 feed lines, but I have them. Okay, take 2, it's done. There's copper everywhere, it's good. I have both my lathe hose and then this hose over here. I'm gonna run these at full tilt for a couple of seconds while looking at the gauge over here, just to see how much droop we get, assuming both people are being dumbasses with the air hose. Okay. You can't see it, but we're at 4.5 bar. I mean, it barely moves, so this is fine. It's fine. So there you go. I mean, this took way longer than I was expecting and it cost way more, but for a real quick job, I'm just gonna knock this out in a few hours. Yeah, it took a lot longer than that, but now for the future, I have all this extra copper, I have some extra fittings, and now I have that hydraulic crimping tool, and that thing was way better than I was expecting. For $100 for like a ProPress compatible tool, when the next cheapest one would be a Milwaukee tool, the M12 electric one. I think those are, you could pick them up for $1,000, which is, 10x gap. Anyway, there's today's quick, simple job. Finished. Bye.